Hey everyone. In this new series, I'm going to be talking about behavior trees in Unreal. So I've gotten a lot of requests for this one, and I think what happens is people want to go jump in and use behavior trees, and it gets kind of daunting. There's a bit of background that you need to understand in terms of like when to use them, how to use them, and the various nodes and all of that kind of stuff. So my plan is to go through that. First, I'm going to start with actually the prereqs. So this is what I expect you to know. It's going to be aimed primarily at technical designers. So I'm going to expect some level of scripting. You don't have to be a full-on programmer or anything, but I do expect you to understand some basic things. Specifically, I'm not going to really go over anything in Blueprint. I'm going to show blueprints, but I'm not going to go over like what is a node, how do you drag things over, what's basic, what are basic programming concepts like branching and creating loops and all that kind of stuff. I'll point out things that are a little more specific to Unreal, but I'm not going to go over a lot of the really simple stuff. So I expect you to know Blueprint. I also expect you to know the Unreal architecture. Basically, I'm going to say Unreal Actor System specifically. So you should know what an actor is. You should know how to drop actors into the world and how to move them around and the basics of that. Like I'm not going to specifically go over things like animation and that kind of stuff. I'm going to toss some actors in the world and have them move around. So I have some goals as well. Besides obviously, behavior trees in Unreal, a few goals and a few things that I found limiting or of limited use in other systems. There's sort of no deep dive into making AI. I think almost all the time when I've seen people making AI, it's like, I have this guy and there's these patrol points and I'm going to go from this patrol point to this one and then maybe back and along comes the player and I'm gonna maybe I'm gonna look at the player or like immediately attack the player and immediately go back. So there's no nuance. The vast majority of AI work, I think, is not getting the enemy to look at you and shoot at you. Most of it is all the little edge cases. You do it and you're like, wow, this doesn't feel right. What can I do to make this feel better? So it's not just going to be, I'm going to look at you and shoot at you. Certainly that'll be a thing. But it's going to be a little more in depth than that. That's the goal. I'm going to add, it's going to be moderately complex, but still, I think, simple enough to be able to see. The entire behavior tree itself fits on one screen. So it's not insane. It's enough to show what it is. 100% of this, a slight disclaimer, especially for the programmers in the audience, I'm doing 100% of this work in Blueprint. I may point out a couple of places for the programmers. I might have some secret like programmer asides. I don't know, I'm making stuff up where I might say, hey, if you want to do this for real in like a system that has hundreds or thousands of agents, probably this is something I might move to C++ or something like that. I'm going to try and avoid a lot of that stuff. Mostly I'm going to stick with the design side of things. So my goal is to create that. Another thing that I find missing from people, from tutorials and things that I've seen, it's like I think the biggest issue that I see, I think there are two major issues. Okay, so number one, they simply, so not enough background. That's probably my biggest issue. Right, you have to understand the background of what a behavior tree is and what each of the nodes does before you can hope to dig into like actually creating them in Unreal. So they talk about the mechanics of it, but they don't go into that. And then two, they just don't go into enough depth. Those are two of my major issues. A third sort of issue is that they're just sort of like bad AI. It's like a dude runs up to you and shoots you and then runs away and like does stupid things. So hopefully, I'm not going to have any of those. The AI I'm going to make is very simple, but it's also a reasonable first pass for a game. Four, and this is more of a pet peeve of mine. Four is it's just some kind of test world, right? Those are the four things. And so I'm gonna sneak in a programming joke. I'm going to do the inverse of that. 1 over anything is considered the inverse in math. So that's my joke. Okay, let's jump into this. So a behavior tree is a tree-like structure. And it starts with what's called the root node. There's some node. So a tree, very, very abstractly, is sort of a data structure that looks like this. It has these, what we call children. Maybe this one has 3 or maybe 4. So this is a basic tree structure. So the anatomy of this tree is that we have this guy, which is called the root of the tree. Everything starts at the root. I'm going to label these. So you're going to be A, B, C, D, and so on. And I don't really care. So I'm going to say here, B is a child of A. A is the, not A, the parent of B. C is a sibling of B. If I furthered this, E, F, G, I don't care about this. So if I furthered this like this, then E is the child of B, right? Or F is the child of B. G is a child of C. A couple things to note here is this the. Anything in the tree can have, here, I'll actually do one more thing. All of these little things, I'm probably going to use these terms. These are very common programming terms. These are called nodes. So any of these little circles here are called nodes. And then I'm going to say arcs, or also commonly edges, are these guys. So these are edges or arcs. These are interchangeable things. So this is just terminology. This is true for all trees. This is just tree terminology. So the root is at the very top. There's only one. Nodes are these little, in our case, these circles. They're the things that do things. And edges or arcs are the connective pieces between nodes. They connect nodes. That's literally what they do. So that's kind of it. That's how trees in general are defined. That's the terminology that you need to know when dealing with behavior trees. A behavior tree, I think, was really popularized in Halo 2, which was what, 2004? That's my understanding of when it was really kind of popularized. There's a colleague of mine who is, his name is Damian Isla, a very, very smart guy. He's in the AI Game Programmers Guild. He's done numerous talks at the Game Developers Conference. I suggest, I may link to some of his stuff for fun. He was deeply involved in that first implementation. I don't know if he actually wrote the whole thing, but he's generally credited as one of the main people who popularized behavior trees as a general AI solution. I would say that the vast majority of shooter games that you play are going to have a behavior tree driving the core behavior. They're very, very popular right now. for our purposes in this discussion, we're going to say that there are two types of nodes. So I'm going to go over here. Now we're going to start talking terms. There are two types of nodes. There are task nodes, and there are what I'm going to call composite nodes. Oh no, where's this? I'm also going to go back here and retcon something a little bit in saying that one more piece of terminology we need is that the node, any node at the bottom that has no children, a node with no children is a leaf node. It's a tree, it's a leaf, get it? Okay. By the way, it's called a tree. If I were to take, the reason why this may not look super much like a tree is you kind of have to look at it upside down to make it look like a tree. So now what I want to do is, hold on, let me reset the canvas, and then we'll go back over here. And so let's talk more about this stuff. These are the two types of nodes that we're going to care about. So tasks, tasks do stuff. It is the execution. Composite nodes composite nodes control how the tree is processed. So these are the two things that we have access to. We have a lot more than this, but I want to start really, really, really simple. So a task is doing something. A composite node is controlling how that is processed. Now, let's talk about composite nodes. So there are two kinds of composite nodes that we care about, really. Selectors and sequences. And I'm going to represent these with icons. So I'm going to represent a selector like that. I'm going to represent a sequence like that. That's supposed to be an arrow. So these are two symbols I'm going to use to represent these things. So a composite node does nothing but figures out how to execute how the tree is processed. That's all it does. Tasks do stuff, and they can succeed or fail. In fact, you should really think about it. A better statement is to say nodes can succeed or fail. That's a really important thing to comprehend and to sort of understand. Nodes can succeed or fail. Okay. Let's think about a really, really, really simple really simple like tree. This is going to be very, very basic. Let's say that we want to have an AI where the enemy attacks the player. If the enemy can't attack the player for any reason, maybe there's no line of sight, or they can't reach you, they can't path to you, then we want them to taunt you. And if they can't taunt you, we want them to just idle. So we want to select one of three possible behaviors. So that's what a selector is for. A selector selects between behaviors. So if we give that example, let's look at what that looks like. And I'll keep these here so that we can know what they are. So we start in Unreal. Everything starts with the root node, and there's only one child of the root node. That's just how it works in Unreal. Other systems work differently. We have a selector. Now the selector itself has no behavior. There's no task. There's no nothing's going to run. You're not going to shoot anyone with this. So in order to work, all composite nodes, so selectors and sequences, need to have children. And so we're going to have three. we're going to have one that comes down here that says, attack. By convention, I think I'm going to use rectangles for tasks. We're going to have, what did I say, taunt. And then we're going to have another one here that says idle. So that's it. In Unreal, this is basically what you would do. Now let's give another example. Let's give an example of a sequence. And again, everything starts with the root node. So, sequence. A sequence says, do this, then this, then this, then this. That's all a sequence does. If with the caveat that if any of those things fails, then the sequence is aborted. So, for example, what I want to do here, let's say that we want to make this a little more complicated. Let's say that we want to have a move to player. Maybe we want to scream, whatever, yell at the player. Maybe we want to, oh, I know. Oh, I just thought of this. Maybe we want to taunt the player. That's even better. And finally, we want to attack the player. This is a sequence. So let's think about some of these a little bit. So let's say that I'm going to come down here. So this guy is, let's do this in a different color. So I'm here. That's not what I wanted. I wanted this one. So I'm here. I'm going to come down here and attempt to attack the player. Let's say I can't attack the player. I failed to attack the player. Maybe I'm not close enough. Okay? So we cannot attack the player. So what we're going to do is we're going to try and do the next thing. All right? Can we taunt the player? And maybe we can taunt the player. Maybe this succeeds. So I'll just fill this in. And then we say, yay, right? We can attack the player or taunt the player. And so then this action will run. And when this action is done, what it's effectively going to do is it's going to come back up here, succeed this node, and the tree is basically done because it's a simple tree. So we're good. If in another world, we come down here and we say, what are we going to do? We come down here and we fail to attack the player, and we come back. I'll do all of them. And we fail to taunt, and then we, for some reason, fail to idle. Like, we're going to fail, but it doesn't matter. It's going to rerun the tree anyway. This whole node will fail, and so on. Same thing. Let's look at this. Let's look at this guy. So we're going to come down here to the sequence, and we're going to try and move to the player. Oops. Let's say that we are able to pathfind to the player. Yay. So we have succeeded pathfinding to the player. Now we're going to try and taunt the player. And let's say we succeed at that. And then maybe we're going to try and attack the player. And let's say we succeed at that. Right? And so then we succeed here, and everything is good. If any of these fail, let's say that we can't make it to the player. So let's delete this. Let's say that we can't make it to the player, right? So we're here, we come down here, and we're like, uh-oh, we cannot do this. Well, this is going to come back up, and it's going to fail. Sad face. These are not even going to be attempted to run. We're not even going to try and run those. It's the same thing over here where... So let's say that we come in here and we succeed here. So then by definition, this would fail, right? So we couldn't attack. Instead, we taunt. And we succeed at taunting. This isn't even going to run. We're not even going to try and run it. So it's important to understand that's like the fundamental difference between selectors and sequences. A selector will select the first node that it can that succeeds. That's its job. It's common to have selectors at the very top of your hierarchy because you're going to select one of a million behaviors, you know? Can I see the player? Can I do all this stuff? And based on that, you're going to make your choice. Sequences are really good for do this, then this, then this, then this. And if anything fails, that whole sequence is aborted, right? I can't attack the player if I can't pathfind to them. So that's the difference. Okay? Selectors are meant to basically select a succeeding behavior. Sequences are meant to run an entire series of behaviors, and it will run them all. Now, another way to think about it, and this is, you know, what I said is all true, but this is just another conceptual way. Sometimes this helps people to think about it this way, is a selector will attempt to run all of its children as behaviors until one succeeds, and then it will stop. A sequence will attempt to run all of its behaviors in order until one fails, and then it will stop. I don't know if that's more useful to understand. This is one of those things that you might need to watch this section of the video a few times. Selectors and sequences are, for a lot of people, the most confusing part of how this stuff works. When we go to talk about the actual design of things, I will dig into that more thoroughly. So I'm going to grab this whole thing. Oops. That's not what I wanted. Let's pull it down here. Ready? I can mix and match this stuff as much as I want. Let's kill this root node. Right? Watch this. I can do this. This may not look pretty. It's fine. I'll just do this. There. So, what I've done here is instead of having just some nebulous attack, I've defined it. So I've basically said, hey, this whole thing is my attack. This is what it looks like. It's a melee character. What I want to do is I'm going to try and do this sort of sequence of things. So this gets to be a little crazy. This is where things get a little nuts. So you just walk through it. This is the best thing to do. You just walk through it. Okay, we know what a selector does, right? We know, oh, that's too much. That a selector is going to look at its first node and it's going to say, hey, does this succeed? Well, does a sequence succeed? We don't know. The first thing it's going to do is it's going to try and, right, so we're here. It's going to try and move to the player. Let's say that we succeed at moving to the player. So let's say this is like, yes, we succeed at moving to the player. So then it's going to try and taunt over here. Let's say, okay, we succeed at taunting. Now let's say that we try and go over here to attack. And let's say we succeed at attacking. So if all of these succeed, that propagates up to the parent. So this parent succeeds. So that comes up here. And then this guy succeeds. And that comes up here. And then it doesn't really matter. So in this case, everybody succeeds. Why? Because a sequence succeeds if and only if all of its children succeed. Otherwise, it fails. A selector succeeds if and only if any of its children succeed. Okay? So I know there's a lot here. There's a lot to kind of take in. I would watch this section a couple times, try and get what this really means and understand why this works. So if I were to do this again, with a different example, let's say this guy comes down, right? And we come down here and we say, okay, let's try. And maybe I can move to the player. So maybe this succeeds. And maybe taunting for whatever reason fails. You know, I don't know. Or better yet, this will succeed. Why not? And then we come over here to attack, and then attack is the thing that fails, right? Let's say this fails. We can't attack for some reason. So what that's going to do is remember, it succeeds if and only if all of the children succeed. Not all of them succeeded, so this node is considered a failure. That means this is going to propagate up. You failed. That's bad. However, it's a selector. It doesn't care if one of its children fails. What does it do? All it does is it goes to the next one. So now we're going to try and taunt. So you'll get like a double taunt happening. And probably this succeeds because our taunt down here succeeded. Notice we have taunt here and here. In reality, these are probably literally the same node. So if I were to take this taunt and blow it up, there would be some, blueprint thing here, right? There's some code in here, some script in here that makes taunting work. Probably you face the player, you play an animation, whatever. So taunting is probably literally the same blueprint call in both of these cases. You're just dragging the node in two different places. So it lets you share behavior. If you write a complicated script that says this is how this thing works, it's really easy to just share that. All right, so I'm going to stop for now. This is the basic theory. Try and really understand these selectors and sequences and really get a chance to understand how these composite nodes work. Selectors and sequences are the key to understanding a behavior tree. We want to get to the point to where we can look at a behavior tree and sort of intuit what we think is going to happen. In the next video, I'm really going to talk more deeply about task nodes and kind of the elephant in the room, which is being able to do some kind of branching if statement or something like that, and just understanding how Unreal does that. So we're going to talk about that in concept, and we might do a little bit of just kind of demo stuff. So that's it. Yeah, I'll see you next time.